Okay, this is a review over graphing in hurricanes. We started this in class, but this is just in case you weren't quite clear on it or just needed a little bit more explanation because we didn't have a lot of time and we kind of finished class in the middle of this. Okay, so this is a short review. So what we decided is that a normal graph in math class looks like the one on the left. So we have our axes, right? We have our x-axis right here. We have our y-axis right here, up here. So if you go to the right, you're going positive, so your positive x's are to the right, your positive y's are up instead of down. And that's just a normal graph. So like if you have a point here, so that point is 2 spaces to the right, and it's 3 spaces up. So this point then, we're going to do our x, y coordinates. So this is going to be x and y. So we went 2 to the right, so we have a 2. We went 3 up, so we have a 3. So that's our coordinate. That tells us where it is. In some of the other directions, like let's say you have a point back here somewhere. So in this case, we're still going to do our x and y, but we went to the left. We went 1, 2, 3, 4 spaces to the left. So we know we're going to have a 4. But we need to tell it that we went to the left, because if we just leave it as a positive 4, that tells people that we went right. So since we went to the left, we're going to put our negative. So we have a negative 4. And then we went up 2, so our y coordinate is a 2. So our coordinate pair is negative 4, positive 2. That tells us that it's over here to the left is right there. Okay, so a long time ago when they started exploring things, they decided that we needed to be able to find position like on the earth as well. So like they were out in their little sailboats, maybe they discovered gold somewhere, and they wanted to take it back to England, but they wanted to be able to come back and get more gold, so they needed to create a map so they could find that. So what they did is they did it just like graphing, only in this case, up is north, down is south, to the right would be east, and to the left would be west. That's not a very pretty arrow. Let's see, let me make that prettier. Ta-da! So then maybe they started in England and they say, okay, well our gold, we found our gold at, let's say 10 degrees to the east, say that's a 10, and 40 degrees north. Probably in the middle of the ocean somewhere, we're just going to pretend. So they would have a point like right here, and they would give their coordinates. It's 10 degrees east, 40 degrees north. But when they give coordinates on a graph, so let me put down here, this is a map. Okay, when we give coordinates on a map, we're not going to do x and y. We're doing north and east, or north and west, or south and east or west. But you're going to give your north coordinate first. Now remember before you had x and then y. In this case, you're going to have your north or south coordinate, and then you're going to have your east or west coordinate. So you're going to have, in this case, since we were at 10 degrees north, we were 10 degrees east, we were 40 degrees north, we're going to have 40 degrees north, 10 degrees east. And what they would usually do is they would put like 40 degrees in, 10 degrees E, so that you realize you're going east and not west. But so basically a map is just a graph. So what we decided then is that we can chart hurricanes. Okay, so this is Hurricane Jose. This is right now, this is the 13th of September. This was like the latest update, which is 4:31 Eastern Time, 3:31 afternoon our time. And Hurricane Jose is right there. You can see them all in red. Hurricane Jose. And what they said that his position is, they said, okay, he is at 25.3 degrees north, and he's at 65.6 west, 65.6 degrees west. We definitely want to know these things. We want to know where the hurricanes are. We want to know where they're going. We want to know how fast they're going to get there. So we're going to use a map to do these things. A lot of times if it has to do with water, instead of calling it a map, they'll call it a chart. So in this case, this is a hurricane tracking chart or a hurricane chart. So this is Jose. This is where he is now. So I looked online and I was like, okay, well, where did he start? This is where he is now, but he didn't just start there. He started somewhere. So Hurricane Jose, as it turns out, started, let's see, let me write this down. Okay, so he started at 12.3 degrees north, 12.3 degrees north, and 39.1 degree west. West, of course, means we're going to the left. And we're going to the left from what we call the prime meridian. That's like your axis. That's your zero. It goes right through England, since they were the ones kind of developing this at the time, so they got to claim that as zero. If we had been developing this, we probably would have put zero through New York or Washington, D.C., but we didn't start this. So where he is now is he's at 25.3 north, and 65.6 degrees west. Okay, so let's plot that then. If we come up here on our chart, let's see here. You notice there are numbers on the side, so these horizontal lines that are going upward, these are your north coordinates. So if we want to start, okay, his first point was at 12.3. So that's like somewhere around in like this area. And he was at 39.1. Okay, so 39.1. So this line right here is 40. So that's 40. He's at 39.1 and he's at 12.3. So that's going to put us, if this one is 10, 12, so about right here. That's his first point. So now his point where he is right now is he is at 65.6 west. Well, this line right here is our 65. And he's at 25.3. Okay, this is our 25. So 25.3, 65.6. So that's going to put us like right in here somewhere. Okay, so he started down here, he ended right there. Let's draw a line. He's kind of wobbled along the way, but we're just looking at his line right there. Okay, so he went from there to there. So we tracked him, and that was good. But now that's not all we did in class. What we did in class is we decided that we could calculate how far it went. And what we're going to do is we're going to use our Pythagorean theorem. So let me copy this. Let's see here. Maybe not. Okay, let me go to the next page. Well, yeah, I can copy this. Okay. That's why I like the iPad, is I could copy all of these things. I could copy, paste. Oops, that didn't paste. There we go. Oh, okay, I didn't copy my graph. Okay, that's okay. So this was on our chart. Let me take this part off because this is ugly. Let's erase this part. Let's clean it up a little bit. We don't really care about this 40 thing right now. We'll take that away. What we're going to do is we want to find the distance that he's traveled. So this right here, this 12.3, this one is our starting point. This one over here is our finishing point, so let's put that over up here. Let's get this out of the way. We're just going to clean everything up. Okay, so we have our starting point, we have our end point. Let's label these. So this is our first north coordinate. We're going to call it N1 for the first north. This is our first west coordinate. We're going to call it W1. This is our second one, so this is our N2. And this is our W2. So now we have the two parts of our points, right? So in geometry, we did our little Pythagorean theorem when we had triangles. And what we said in geometry was, let's see, if you have a triangle that looks like this, And this is a right triangle, so we'll just do that. Then what we said is that if you know these sides, you have like A, B, and C. And C is your longest one, is your hypotenuse. What we said is we know that A squared plus B squared equals C squared. That's our Pythagorean theorem. So if we want to find the distance that a hurricane traveled, all we really need to know is we need to know this distance, and we need to know this distance. Well, those distances are actually not that hard to find because we know our north and west coordinates. So we have this point here, we have this point here. This distance here, this is our A. Our A is really, it's like the change that we went in our west, right? It's like how far it went. So A is W2 minus W1. It's like the difference in our position. So in this case, this would be like 65.6 minus 39.1. And you could use your phone or calculator on this. This isn't something you really have to do in your head. I mean, if you want to, you could. You're totally welcome to do that, but you don't have to. So using the calculator, this distance was 26.5 degrees. 26.5 degrees. We're not used to distance being in degrees, but in this case it is because it's, you know, it's a navigational thing on the earth. We can convert this back to miles. And we'll do that again here shortly. Okay, this is our B side. And our B side is the distance that the hurricane went in the north or south direction. So to find B, this is just going to be your second north coordinate minus your first north coordinate. So in our case, this is like 25.3 minus, where did I put this? 12.3. Let's put our minus sign down here. Well, that's easy enough. That's 13, right? Because our 0.3's canceled, and we have 25 minus 12. That gives us 13. Okay, so we have our A value, we have our B value, and now all we need is our C value. So if A is 26.5, B is 13, then our A squared plus B squared equals, so we have 13 squared, that's our B squared, plus 26.5 squared. That's going to be a pretty big number. I'm not going to do it in my head because I don't want to. I don't want to. So we're going to go 26.5 squared plus 13 squared. That gives us 871.25. This is still in degrees. That's our C squared value. So then for the distance itself, we got to take the square root of both sides. I'm going to put this in green so we can see what we did. So we're going to square root this, we're going to square root this, and this is going to make, so we have, that's my dog, sorry. So we're going to get, okay, so that gives us 29.5 degrees. That's how far it traveled. So then, to find that in miles, we can convert. So let me go to a fresh page just so it's easy to see. So we have 29.5 degrees. That's how far we traveled. To change this into miles, you just have to remember the conversion factor that 1 degree on a map, so 1 degree, is equal to 60 miles. And this is nautical miles. It's slightly longer than a regular land mile, but it's fairly close. It's like 6,040 feet or 6,011. I'd have to look that up. Whereas a land mile is like 5,280 feet. Okay, we're just wanting it in miles. So what we would do is we would say 29.5 degrees times 60 miles for every 1 degree. So when we multiply, the degrees are going to cancel out. These units are going to cancel out in the top and the bottom. This goes away, and what we're left with is 29.5 times 60. So 29.5 times 60. So Hurricane Jose has traveled 1,770 miles. 1,770 miles. So that was a long explanation. This is longer than most of my videos are going to be, but this is just kind of a clarification, like if you didn't understand what was going on or if you missed the class. So I'll try to keep it a whole lot shorter than for now on. This is over 15 minutes, which is way, way, way too long. But it's just a review. Okay, see you in class.